In this section, we're going to talk about exponents, square roots, and the order of operations. Now, an exponent, you're already used to this. Let's say we have something like 3 to the 4th power. The 3 is called the base, and the 4 is called the exponent. That exponent tells you how many times the base is getting multiplied by itself. So in expanded form, this becomes 3 times 3 times 3 times 3, 4 different times, and that product turns out to be 81. You can think of this as 9 times 9 to get that 81 if you want. Now, when the exponent is a 2, and you have something like 5 to the 2nd power, we use the word squared, 5 squared. That represents 5 times 5, which is equal to 25. Don't make the mistake of ever going 5 times 2 to make that 10. And if we have something to the 3rd power, like 4 to the 3rd power, 4 times 4 times 4, which is 64, this 3 here is pronounced cubed. You can't say 4 cubed or 4 to the 3rd power. The word square for an exponent of 2 and cubed for an exponent of 3 are two special words we use because it shows up so often, and we don't have any special words for any other exponents. Now, let me call your attention to something else. If I have something like negative 2 to the 3rd power, that is equal to negative 2 times 2 times 2, which is negative 8. Even though it's pronounced negative 2 to the 3rd power, it's only 2 to the 3rd power that's becoming negative. That exponent we say is nearsighted, so to speak. You can only see what it's directly next to, and only the 2 is getting raised to that power. If you wanted it to be negative 2 times negative 2 times negative 2, you would have to put parentheses around that negative 2. And I'm going to make that a big point when we get towards the end of the course and we start talking about signed numbers. Now let's take a square root. This is our square root symbol, and when we want the square root of 36, that is going to equal 6. And the reason that's 6 is since 6 squared is equal to 36. Right now you can think of a square root symbol as something that undoes perfect squares. It's not exactly that case, as you'll see in a couple semesters, but for now that works. And if you have something like the square root of 100, because 10 times 10 is 100, that will have an answer of 10. Now we're going to move on to the order of operations. Now this is something that's going to be with you throughout this course, and we're going to keep doing it over and over again as we learn new types of things in this class. Now, we usually use this phrase, PEMDAS, representing please excuse my dear Aunt Sally. P stands for parentheses, E for exponents, which includes square roots, M and D represent multiplication and division, A and S represent addition and subtraction. Now, multiplication and division are equally important. We do not do multiplication first and then division. It depends on whichever one shows up first from left to right. Likewise with addition and subtraction, whichever one shows up from left to right, that's the one we do first. Sometimes it's the subtraction, sometimes it's the addition. And so this is a very organized process to help us get the right answers when we're working out some of these problems. Now let's work on this first problem. 14 plus 10 divided by 2. I've written the initials here of please excuse my dear Aunt Sally up in the upper right corner here so we can use it as a reference as we move through several problems. We start by looking for parentheses, which we see none, then exponents, and there are none, and then we move on to multiplication and division. Well, we see addition and division. Division comes before addition or subtraction, so we're going to do this 10 divided by 2 first. That's going to give us a quotient of 5. Then we have 14 plus 5, which we then perform to get 19 as the result. In this next problem, there are no parentheses, but we do see an exponent, and we know to do that 3 squared first. 3 squared, 3 times 3 is equal to 9, and so we have 15 minus 9, which is equal to 6. In this next problem, there are parentheses, and that says do what's inside the parentheses first. So inside this parentheses, we see subtraction. 8 minus 3 is equal to 5, and then that 5 gets squared. 5 times 5 is equal to 25. And that would be the answer to this problem. In this next problem, we again see parentheses, so we want to do the addition inside the parentheses first. Not because addition comes before subtraction, but because that's inside the parentheses and that takes precedence. 12 plus 18 is equal to 30, and then we have 42 minus 30. Now I could put the parentheses around the 30, but if there's only one number inside, there's really no reason to keep those parentheses, so I'm going to drop them. 42 minus 30 is equal to 12. Again, in this next problem, we have parentheses, so we're going to do this division inside the parentheses first, which is going to give us 4. So we have 11 minus 4 plus 7. And here we have subtraction and addition, which are equally important. Because the subtraction shows up first from left to right, that's what we do first. 11 minus 4 is equal to 7. Bring down our plus 7 from the line above, add together, and get 14 as the answer. Again, we're going to begin with expression inside the parentheses. 19 minus 17 is 2. So we're going to have 2 squared times 4 minus 3 squared. There are no parentheses, so we move on to E for exponents. And the first exponent we see is here at the left, so that's what we're going to do first. 2 squared is 4 times 4 minus this other 3 squared. We're going to do the next exponent we see because exponents are still our higher priority. 3 times itself is 9. So we have 4 times 4 minus 9. Multiplication versus subtraction. Well, multiplication is more important. It shows up first before the subtraction. So 4 times 4 is equal to 16 minus the 9, which gives us 7. Now, one last comment I'd like to make is that of the parentheses here. Parentheses can be used for different purposes in mathematics. Sometimes parentheses say, look here, I have a math problem inside that needs to be done. But at other times, 5 times 7, these parentheses indicate multiplication. This would take place at the M multiplication phase, whereas the one on the line above, which actually has an expression inside that can be evaluated, that's the one that we're referring to when we're talking about the order of operations. So don't just indiscriminately, anytime you see parentheses, always do the multiplication. Wait and look more closely at what's going on. It's the expression within parentheses that we're referring to with this P.